So happily, since you all know Ruby, it's going to be really easy, I think, to pick up JavaScript if you haven't programmed in it before. If you have programmed in JavaScript before, you may find that you've been using the language maybe in suboptimal ways, or maybe not taking advantage of everything about the language. And now, hopefully, you'll be able to do so. Now, by the way, I said that I think our JavaScript treatment in the book is pretty good. There's obviously much more detail and more examples in the book than we can spend time on in the lectures. So don't assume that the lectures are going to give you enough coverage to go write code on your own. To learn to write code, you have to write code. But the book has a lot more detail on JavaScript than we're going to cover here. Nonetheless, in terms of hitting the high order bits, JavaScript is interpreted. It's just-in-time compiled these days for the most part. But the model is that it's an interpreter. Like Ruby, it's dynamically typed. So objects have types, but the variables that refer to those objects do not have types. So right there, that's a difference that's totally unlike Java. There are no classes. A lot of people use JavaScript as if it had classes and inheritance. It really doesn't. It has something that we're going to introduce called prototypal inheritance that actually comes from a fairly obscure research project. But the sort of classical inheritance that we think of with subclasses and superclasses, JavaScript doesn't have that. So it's object-oriented, it has inheritance, but it's a different kind of inheritance. And although you can use that inheritance to build something that looks a lot like classical class inheritance, I would not advise you to do it. I'm a big fan of, if there's a tool available, you could either figure out how to use it properly or choose not to use it, but don't misuse it, right? Don't hammer in the screw. The basic object type in JavaScript is essentially a hash. So kind of like a Ruby hash, the keys are called slots or properties. Unlike a Ruby hash, the keys generally do have to be strings. So remember, in Ruby, you can key a hash on pretty much any type of object. Not so in JavaScript. Here's a simple syntactic example of an object that I'm assigning to the variable movie. It's got a title slot or property. Slot and property are the JavaScripty ways of talking about hash keys. It also has a release info property. And the release info property, its value is, in turn, another object. So objects can be nested. The value of an object's property can be another object. In fact, the value of an object's property can be any legal JavaScript object. You notice that I didn't put the quotes around title, but I did put them around release info. Quotes are always legal. And in fact, if you're using the JavaScript object notation, or JSON, which we'll talk about a little bit later, you do have to put the quotes in. But for JavaScript itself, you can leave the quotes out if you want, as long as the slot name also would be a legal name of a variable in JavaScript. So for example, you can have a slot name that includes, let's say, a hyphen. But because a hyphen would not be part of a legal variable name in JavaScript, in that case, you would have to include the quotes around the slot names. We're going to do a couple of demos using a JavaScript console window. But the best way to sort of play around with JavaScript, and for that matter with jQuery, is to just open, use a browser that has a good JavaScript console. Firefox or Chrome are probably two of the better ones. And just try things out interactively. So we'll be doing some of that as I demonstrate a few JavaScript features. Variables. The keyword var exists in JavaScript, and you use it to restrict the scope of a variable, for example, to the function in which that variable is declared. If you don't use var, or if you use it in the outermost scope, that means outside the scope of any other function, then basically you're declaring a global variable. And if you haven't figured this out by now in your undergraduate careers, that's almost never what you want. The one exception is because the only way to share data across JavaScript objects is through the global namespace. A standard trick that we'll see that you use is when you're declaring the functions or variables that go along with your own app's code, a nice practice is to declare a single global variable and have the values or the properties of that global variable correspond to your functions and to the other data that you need to track. Functions are first-class objects in JavaScript. This is really important for a couple of reasons. And they'll become obvious, especially when we talk about AJAX. But first-class object means you can pass a function around. You can return a function as a value. You can do anything to it that you would do with a simple type, like a string. Functions are also closures. So just like in Ruby, when there's a variable that's in scope at the point where a function is defined, it stays in that scope when that function is later executed. This is going to turn out to be really important when we do AJAX programming, because what's happening is there's a moment when you're making a call to the server, and at that moment, you're registering a function that is going to be called when the server replies back to you later. So it's really useful that at the moment you're doing that call, you know that all the variables in scope for that callback function are still going to be accessible much later in the future when the function is called back. So if you kind of put these things together, a very common pattern in JavaScript is passing functions to other functions. And a very common pattern is to have functions as property values. So having an object, some of whose property values are actually functions. And you'll see that they sort of look and feel a little bit like instance methods. Although, again, I don't want you to fall into the habit of thinking in terms of classic inheritance in classes. So as I said, a best practice to sort of keep the global namespace from getting polluted is to sort of declare just one global variable that your app is going to use and keep all of your functions and all of your data inside that global variable which you assign to an object. So you basically have one big object, and that's all of the stuff that your app is going to do. That's how we're going to run most of our examples. Now, that's not to be confused with the global object. The global object is a JavaScript-specific language construct, and it refers to an object that is provided by the runtime system. So if you're running JavaScript in a browser, the browser provides the global object. And the global object defines certain constants and functions that are part of JavaScript's runtime environment. So for example, you get at the browser's built-in version of the JS API, JavaScript API, by calling functions that are defined as properties on the global object. And whenever you see the keyword this, so this behaves a lot like it would in Java. We'll see that when you call a function that is a property of an object, the value of this in the function is what you would expect. It's basically that object's instance. But what happens if you use this and it's not in the context of where you would expect that there's any receiver? Well, in that case, this, by definition of the language, means the global object. And again, this is almost never what you want, and it's a big design defect in JavaScript that results in a lot of silent failures. We'll see an example of one shortly. In the case of the browser, one of the things the global object defines, and in particular the value of this, is the top-level object representing the document that got loaded. And access to all of the JavaScript API essentially is through that global object. Each page that is loaded in the browser gets its own copy of the global object. So for all practical purposes, those pages are all separate. That also means that any JavaScript that you want to have executing has to be loaded for every page that would possibly need it. And as usual, Rails has a nice way to help you out with this. If you say JavaScript include tag application, this will include a file called application.js. You'll see that there's a manifest in that file where you can add the names of all the other files that contain your own custom JavaScript code. Now, why would you use and by the way, when you expand it out, if you look at the pages that are generated, what you'll see is that it just generates a script tag that loads that file and possibly some other files. And if you're using jQuery, as we'll see, it generates a tag for loading jQuery as well. The reason that I would encourage you to use this JavaScript include tag helper rather than hard coding a tag like this into HTML is that, again, when your app goes into production, there's a number of nice optimizations you'd like to be able to do so the users get better response time. And one of those is you'd like to be able to take all of your JavaScript files. So in a typical app, if you're doing non-trivial JavaScript code, you're going to end up with 10 or 15 or 20 JavaScript files, right? A lot of little files is always better than one big Mongo file because it gives you a nice way to keep your code separate and testable and so forth. So the production environment in Rails has this nice piece of functionality called the asset pipeline, where anytime that you change your JavaScript files, it will essentially reconcat them all together, minify them, which means essentially compress out the white space and do renaming and stuff like that. So it's obscure but a lot smaller. You can cut files down by more than a half, potentially compress them, and serve them out of a cache that the web server manages on its own. So basically, all of the static assets associated with your JavaScript files get automatically updated, and they get compressed and optimized for fast delivery. And that all happens in the logic behind this helper tag. And you can miss out on getting that if you manually put the script tag in yourself. So don't hesitate. The bottom line is don't hesitate to spread your JavaScript code across many little files. It makes it easier to test, makes it easier to maintain, and you don't have to worry about the fact that those files are all going to be separately loaded, unless, of course, you are the contractors who designed that front end for the Affordable Care Act website, which actually was loading all those files every time without caching. Remarkable. We've talked a lot about beautiful code. There's now a lot more tools than there used to be to help you write more beautiful JavaScript. And the good news is you can start by using some of the things you already know that are guidelines that really are language independent. So the idea that functions should be short and do only one thing and have few arguments and stick to one level of abstraction, the SOFA goals, there's no reason that wouldn't apply in JavaScript. Keep your code separate from your HTML. One of the worst habits that JavaScript got a bad reputation for is pages that were mixing HTML markup, presentation stuff that really should have been CSS, and logic that really should have been JavaScript. As we'll see, there's no reason to do that, because you can have all of your JavaScript code separate and use just a separate binding mechanism to determine which pieces of code get associated with which elements. We'll talk about Jasmine and the idea that just like with RSpec, you can do red-green refactor to keep your code sort of organically modular as you evolve it. So all of these things you already know how to do. It's just a matter of learning a slightly different tool to do them. And there's also some JavaScript-specific tools that are getting really good. There's a tool called JSLint that goes along with a book I really like called JavaScript: The Good Parts. It's basically, here's some advice for how to use JavaScript wisely and some things to just avoid using because they're broken language features. There's a command line tool that is built into the VM that we distribute called JSL, and you can just run it on your JavaScript files and get metrics back. There's also a site that's relatively recent called JSHint. I have not had a chance to investigate in any detail yet, so I'm not sure what to tell you about it. And as of literally like last week, Code Climate now supports JavaScript. So they'll now do metrics on your JavaScript as well as on your Ruby and Rails application code. So we're big fans of tools, and I'm going to make it my business to learn more about JSHint and decide which ones I want. OK, so here's a question about the browser environment of JavaScript. If you manually open two separate browser windows, can JavaScript code loaded into one of them affect what happens in the other? And possible answers are, well, because browser JS APIs are not implemented compatibly across all browsers, it may depend on that browser's implementation. Or yes, because since JavaScript can access the DOM through the JS API, then this would work. No, because each window has its own copy of the global object, therefore essentially its own copy of the interpreter. Or no, because there's no concurrency. We're talking about two windows, but we've said you can only run one JavaScript thread at a time. So which of these is it?